Welcome to visionnotes.com. Today we are going to deal with some questions related to work power energy chapter of 11th class physics. Now let us see the first question. The first question contains the sign of the work done by a force on a body is important to understand. State carefully if the following quantities are positive or negative. हमें पॉजिटिव या नेगेटिव बताना है कौन सी क्वांटिटी पॉजिटिव है कौन सी नेगेटिव है. फर्स्ट, द वर्क डन बाय अ मैन इज लिफ्टिंग ए बकेट आउट ऑफ ए वेल बाय मीन्स ऑफ rope tied to the bucket. As you can see here, let us draw some diagram here. Whatever the object we are pulling up by the force, enrgy is acting downward and displacement is upward, so force into S, this is our work done. So F dot S means Fs cos theta, and theta here is 0, so cos 0 is 1, so F into S will be positive. Now let us deal with the second, work done by gravitational force in the above case. In this case, gravitational force is acting downward and displacement is upward, so theta will be 180 degree. So if I find out F dot S here, which is our work done, so it will be Fs cos 180, and cos 180 is -1, so it will be a negative quantity, so that is why work done is negative. For the third part, work done by friction on a body sliding down an inclined plane. If we just find out the force direction and the direction of displacement, there is an inclined object, inclined plane here, so it is sliding down, m mass, friction is acting upward, and displacement is in this direction, so work done will be negative. Why so? Because theta is again 180 degree. Let me tell you one thing, if theta is acute, then W will be positive, and if theta is obtuse, then work done will be negative, and if theta is 90 degree, W will be 0. So you learn this and it will be beneficial for you. Now for the D part, work done by an applied force on a body moving on a horizontal plane with uniform velocity. Again, the direction of force and the displacement are same, so work done will be positive. E part, work done by the resistive force of air on a vibrating pendulum, bringing it to rest. If a pendulum is oscillating like in this direction, at this time air friction will be acting backward, so displacement again and friction are acting in opposite direction. Theta is 180 degree, so obtuse angle means work done less than 0. E part is done, so 6.1 is over. Now let us deal with the second question. A body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table. Coefficient of friction is 0.1. We have to find out the work done. So what are the given things? Mass, it is given, horizontal force is given, mu is given. Let us write this. Mass is, what was the mass? You remember that? it was 2 kg. Okay, and then horizontal force and mu. Horizontal force is 7 Newton and mu is 0.1. Okay, now what kind of object is this? A body of mass 2 kg. So nothing is mentioned, so I'll be taking a simple block placed on a table. So work done by the applied force in 10 seconds. Action. The force is acting here. This is 7 Newton and this will move in this direction. So what? Force dot s. This will be our work done, which is Fs cos theta, which is 7 into s into cos 0, because the direction of displacement and force are same, so theta is 0, but I don't have s, so I have to find s. I will find it with the second equation of motion. Why is that? Because acceleration is constant, because force is constant. So I can use this equation. Initially it was treated as rest, so s is equal to 0t plus half a. What is the force here? Force is 7, but one more force is acting here, that is friction force, and normal force and gravitational force is also acting here. So acceleration will be provided by this formula. It is equation for this object along x-axis. Now this is f, this is mu into n again, so ma, and the object is having a mass of 2 kg, so it's okay. But I don't have this n mg. Okay, if I see along y-axis, so object placed here facing friction, normal force. I am drawing this diagram again. External force 7, 2 kg object, this is 2g. Normal force I have to find out, so that I can find friction force, and so that I can find acceleration, so that I can find displacement. So along y-axis for this object, n minus mg is 0, n is equal to mg and m is 2, so 2g. I'll take the value of g later on. And for the moment, friction force here is kinetic friction, so this is mu n, this is mu, that is 0.1 into 2g, this will be 0.2g. Whatever the force is 7. Now along x-axis, f minus f is equal to 2a, 7 minus 0.2 into, I am taking g as 10, so 2a, it will be 7 minus 2, 5 is equal to 2a, a is equal to 5 by 2. So I have the expression now, and now let us find displacement in 10 seconds. 0t plus half 5 by 2 square, 10 ka square, so it's 5 by 4 into 100, it will be 125, and so work done will be Fs cos theta, Fs cos 0, as per diagram. This is 7 into 125 into cos 0 is 1, so the answer is 875. It will be nearby the exact answer because I have taken GS 10. Finally, this question is over and work done by the external force, the applied force we have calculated. Now we have to find out the work done by friction in 10 seconds. As the displacement is same, so friction force, I know that is again taking this value of F, that is 2 into 125 was the displacement, so it is 250. That's work done by friction force. This is B part. See now. Work done by net force in 10 seconds. What is the net force? Where is the net force? This is the net force. This is the net force. This is the net force. And this is 7 minus 2, that is 5. So work done here is 5 into 125. This will be 625. Changing kinetic energy of the body in 10 seconds. According work energy theorem, work done is equal to change in kinetic energy. So the work done by net force is this. So this is also the change in kinetic energy. This is the D part. I'm done here for this question, for the second question, and I'm done here for today. In the next class we will solve third and other questions. Good night, sayonara, keep visiting visitnotes.com.